All right, so today we are going to convert standard form to scientific notation, and vice versa. We're going to be given scientific notation, we're going to have to convert back to standard form. The next time you see this will be in chemistry in high school.
Oh.
Yeah, so my daughter yesterday was talking about scientific notation in chemistry, and I was like, really? So, give it in. So math and science are related a lot. They're both math and science as well. All right, scientific notation. Scientific notation is a shorthand way of writing really large numbers, or really, you got it, small numbers. Scientific notation is written as a product of two numbers. The first number must be between what? 1 and 10. You got it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The second number must be a power of 10. So, converting standard to scientific notation. So we're going to take a few notes and then we'll practice. We're going to create a number between 1. Good. That's our first step. So let's do that while we do example number 1. All right, so look at number 1. Okay, we're going to create a number between 1 and 10 by moving the decimal. Where should we move the decimal? It is here. We have to move it where? How do we create a number 1 through 10? Do I keep going? Yes. Good. Right there. Count the number of times that you move the decimal. This number will be your power of 10, your exponent. Okay? I can put that in parentheses. That'll help you remember. So how many times do we move the decimal? 6 times. Okay, we move the decimal 6 times. If your number is really large, the exponent will be positive. If your number is really small, and when they say small, they're talking about if you're given a decimal. So a number less between 0 and 1, okay? The exponent will be negative, you got it. All right, so is our 1,850,000? What's our exponent going to be? Is it going to be a positive or a negative 6? It's going to be a positive 6, okay? So we're going to write our number in scientific notation as 1 decimal, good, 8, 5, and we drop the zeros, right? Times 10, it's always times 10 to the power of, and now said positive 6.
So we're just writing the equation for it?
The expression. So this, we were given standard form. This is scientific notation. Okay? So let's look at number 3. We're going to convert the number. This is standard form. We're going to convert to scientific notation. Okay? What's our first step? Good. Move the decimal. And where are we moving it?
Pardon, please, pardon me.
All right. So where are we moving it? Where should I stop? Behind the 7. How many times did I move it? We moved it 3 times. Okay? So our decimal will be 7 decimal 8 2, 6. We drop those zeros, right? And it's always going to be times 10 to the power of y negative 3.
Because it was a decimal.
Good. Because right here, if we have a decimal, our power will be negative. Y'all are negative. So with your table, please complete number 2 and 3, and we'll have 2 people come up to the board and share what your table got.
And you can complete either one you want. Good. Good. Let's give her one big clap. 1, 2, 3. Questions? All right. Kira, number 4. Convert the number to scientific notation, please. Good. We moved it 5 times. Good. Let's give Kira one big clap. 1, 2, 3. Questions? All right. Let's go backwards. Now we're going to be given a number in scientific notation, and we want to convert that to standard form. So we need to move the decimal the same number of places as the exponent. Okay? That exponent tells you the number of times you're going to move the decimal, and it's going to tell you direction. That exponent is very important. Okay? If the exponent is positive, move the decimal to the right in order to make the number larger. And then add zeros as placeholders if necessary. If the exponent is negative, move the decimal to the left in order to make the number smaller. And again, add zeros as placeholders if necessary. So if you think of a number line, okay, the right is positive numbers, right? So we want to move to the right if it's a positive exponent, and left is a negative, okay? If that's a helpful reminder for you. So, number 1, convert the number to standard notation. What's that exponent tell us? To the right, how many times? You got it. So I'm going to rewrite it. 1, 2, 3, 4, 5, 6, 7. That's where our decimal will be. Add zeros as placeholders. Okay? And then add commas. We do that. $78,300,000. We're good? Let's look at number 3. What does our exponent tell us? What's it telling us to do?
Go to the left.
Go to the what direction? Left 6 times. 1, 2, 3, 4, 5, 6. Fill in zeros. And then you can have a 0 in front of the decimal as well. We're good with that? All right, so with your table, try number 2 And number 4, we'll have 2 more volunteers. Convert each number to standard form.
Good. She moved a 3 to the left. Good. And you should have gotten 3 thousandths. One big clap. 1, 2, 3. Questions? Clarify anything? All right, Nikhil, you're up. Number 2. Good. One big clap. 1, 2, 3. Is there a way when you're given scientific notation to check your work on the calculator? What could we do? Yes.
Could you solve it and then see if you get the first one?
We just type this in exactly like it is. 2.5 times 10 to the power of 4. Okay, try it. And then it can check your work. Below is more practice. Go ahead with your table, complete the missing blanks, and then we'll check.
Clarify anything? Questions? Alrighty then, if you could get out a device, we'll play a Kahoot for more practice.